Hello and welcome everyone. Myself Raushan Gupta and I'm from second year of BC department from STJ International College. So today I'll be discussing here about one of the data structure, which is queue data structure. So let's begin with it. So as you know that the meaning of data structure is arrangement of data in such a way so that it can be used efficiently by us. Now first of all what we are going to discuss is a queue data structure. So queue is a linear structure which follows a particular order in which the operations are performed. As we know the meaning of linear structure, that's arrangement of data in a linear form. So it follows the order of first in first out, and the best example we are going to see in the next slide what is first in first out. As we can see here the example of a ticket counter where the first person who is getting ticket first, he's getting out first. So on this basis our queue data structure works. Now we have already used stacked, so here we're gonna compare queue and stack. So in a stack we remove the item the most recently added, in a queue we remove the item last recently added. So stack works on the last in first out method, where the insertion of the data which has been in the last will get out the first, but it's opposite in the queue, that the data which has been inserted first will be deleted first. So it's now application of queue data structure. So queue is used when the things doesn't have to be processed immediately, that I do have a time, but have to be processed in first out order, like breathe, first search. The property queue makes it also useful in following kind of scenarios, like I have given a good example of ticket counter in my previous slide, so you can understand it better. So here is also some examples when a resource is shared among multiple consumers, example including CPU scheduling, disk scheduling, as we have already studied in our operating systems about CPU and scheduling, disk scheduling, where it's very important for all the data to be counted at a while. So when the data is transferred anonymously, data not necessarily received at same date as sent between two processes. Examples include IO buffers, pipes, files, etc. So these all are example of queue data structure. Now basic operations which can be implemented by queue. So queue operations may involve initializing or defining the queue. First of all what we have to do is to define queue and utilizing it, then completely erasing it from memory. How we shall try to understand the basic operations associated with the queue. So first is in queue. In queue is something, I'm adding some element to the queue, that is termed as in queue. And I do have a disk queue. Disk queue is an operation is used to remove an item from the queue. Understand? Now there are some more examples. In order to implement our in queue and disk queue, I have to use this all. First of all is pick. Pick is something that gets the element at front of the queue without removing it. It gives me that particular front element, but it does not remove that particular element. Now is full. Check if the queue is full or not. If I want any data to be inserted in my queue, so first of all what I need to do is to check whether the queue is full or empty. Now is empty method is what check the queue if it is empty or not. If I want any data to be deleted, so I need to see if the data is present or not. So by is empty method I can check if the queue is empty or full. Now the most important, insertion and deletion of data. So insertion and deletion in queue takes place from opposite end of the list. The insertion take place at the rear of the list and the deletion take place from the front of the list. If I want my data to be inserted, it will be from the front of the list, and if I want my data to be removed from the queue, it can be from the rear side. So we'll see it about more in the next slide. So how to perform in queue operation. In queue operation I have already told that if I want to insert any element, so step 1, check if the queue is full. So I'm going to use my is full method to check my queue is full or not. Then if my queue is full, then I have to show the error message and have exit from my program. And if my queue is not full, then what I'm going to do, increment my rear pointer to the point to the next empty space, because at the starting rear pointer and initialized pointer both points to the first memory location. Now step 4, add data element to the queue location where the rear is pointing. Fifth, return success. After successing, my element will be inserted. So this we are going to have a picturized format in our next slide, so we can get our idea cleared in this slide. Now I do have a dequeue operation, like accessing data from the queue is process of two tasks: access the data where front is pointing and remove the data after access. Now what I want, a dequeue is something I want to empty my queue. So what I have to do, check if the queue is empty. By is empty method I can check whether it is empty or full. So if the queue is empty, and produce underflow error and exit. Now if the queue is not empty, so I can delete my some of the data if I want to delete. So I will have to do that access the data where front is pointing and increment from pointer to the next available data element. After getting my data to be removed out from the queue operator, I'll show the success message. So here I can have a great algorithm example of dequeue operation. So that's it. It was just introductory video of queue. Thanks for watching my video.